Adam, it's time to thank some people who are on our side because we're on their side. You found a new tool, software, Blue Rhythm commissioning software.
Robert, I sure have. I think Blue Rhythm is what I've been looking for all these years. Building commissioning can be chaos at the best of times. Most projects I consult on really suffer from poor information management. It's 2019, yet the property and construction industry seems to be firmly stuck in the 20th century paperwork world. I think people mistake emails and PDFs and Microsoft files on their servers and all the different PCs as a digital solution. In reality, it's just unorganized chaos. Do you want to streamline your commissioning process and save time and money? Do you want to go paperless and increase efficiency? Blue Rhythm is a cloud-based software solution built specifically for building commissioning professionals. Blue Rhythm digitizes your custom forms and checklists, allows collaboration across project teams, and automates reporting, leaving you to focus on what matters. Their team help you onboard the test sheets you've developed over the years. You can even send it to them in paper, and they will digitize that and put it in the Blue Rhythm system for you. In my opinion, Blue Rhythm pays for itself in time saved on paperwork on a single project. For a demo or to start a free trial, go to bluerhythm.com. That's where rhythm is spelled R-I-T-H-M, like algorithm. bluerhythm.com. Tell them the Edifice complex sent you there.
In a world where high-performance, zero-defect buildings are hard to find, two men are on a mission to disrupt the status quo. Welcome to the Edifice Complex, the Property Design and Development Podcast. Let your hosts Adam Muggleton and Robert Bean keep you up with who is innovating and doing great work, perspective on the adjacent possible, and challenges to the status quo.
Welcome to the Edifice Complex. I'm Robert Bean, your co-host and unofficial mediator, here with my colleague, official agitator, friend, and Yoda of most everything to do with buildings, Mr. Adam Muggleton. Say hello, Sir Yoda.
Hello. Am I in a good mood today? I'm looking forward to this conversation.
Awesome. Today's guest has stated, industry has an imperfect understanding where efficiency and savings come from. That is so true. And that the use of data should be applied to operating portfolios of buildings more efficiently. Also a true statement. Since 2003, he and his team have developed a software infrastructure which incorporates data management, analytics, and enterprise integration. Its purpose to manage the portfolio operational data combined with a service to correct the automation of control systems, which means his market is basically every building on the planet. Welcome to the show, CEO, co-founder of Interval Data Systems, Mr. Bill Gnerre. Bill, welcome.
Well, thank you very much. I'm very happy to be here.
Bill, you graduated from Northeastern University with a Bachelor of Science in Mechanical Engineering. You went on to work for Computer Vision, Formtech, and Channelwave as one of the co-founders there before co-founding IDS. All of our guests tune in here to the Edifice Complex to hear some wisdom and a story. So what's your story?
Well, my story is I started off as a mechanical engineer and practiced mechanical engineering for, half a dozen years, and then moved into the software industry around CAD/CAM and engineering document management. And then the entrepreneurial spirit really hit. And, I ran into a situation where I recognized that the building control industry was not using data effectively. And that started me down the path with Interval Data Systems that combined, data with expertise to understand how buildings operated. And as we learned more and more about why buildings were efficient or inefficient, we eventually identified the source of inefficiencies in buildings is actually the software that runs the building. And that's why we have the title, Why Does It Take So Long? With so much effort to get the control system working to the way you'd like it to work.
Yeah, that's interesting. So just to give a bit of background here, I came across Bill's presentation to the ASHRAE Boston chapter, and the heading was, why does it take so, with lots of O's, long, with so much effort to get your control system running to your satisfaction? So I've experienced this as a commissioning provider for year on year on year. And it's something that's not well understood. In my experience, a lot of owners think the BMS and control system is like magic. It's like an inflatable mattress. You take it out of the box and bada bing, it works. And it doesn't. There's a lot of engineering that goes into it, a lot of setup. And Bill, to me, you seem to have what I call the triple threat skills. You have the engineering background, the systems application knowledge, and then the software data knowledge. That is the trifecta of black belt Brazilian jiu-jitsu in setting up buildings, in my opinion. So kudos on that. But I'd like to talk about this whole situation. So breaking it down, when we were talking earlier, you broke the situation down into 3 parts. Do you want to just run us through those 3 issues?
Well, there are 3 parts. One part is, why does this happen for so many buildings? And then the other part is, what do you do to fix it? And so there's actually, I think, 2 parts.
Right.
And so what I wanted to first discuss was, why does this happen? Because as you mentioned, this happens with many buildings that you've commissioned for many years. And so why it happens really boils down to one very important aspect is the automation software that runs the building consistent with design intent? And in order for that to happen, there needs to be well-written and sequences of operation by the engineer. And then the control company or the control contractor has to write the automation software that's consistent with those sequences of operation. Those are the business rules or contractual terms.
Okay.
And what we've discussed, what we found over the years is there are a number of weak points in this particular process. One is, in general, the engineer's sequences of operation are not as clear and precise as they need to be for efficient software programming.
I'd say that's the understatement of the century, but carry on.
That's correct. Now, why that happens, I mean, mechanical engineers spend an awful lot of time designing the building. They go through studies and, they have to lay out the piping, they have to lay out the ductwork, and they have to figure out all of the ASHRAE standards to follow to deliver the comfort in the space that's required. So we discovered this because we looked at lots of data from lots of building over many years. And eventually we figured out it was the software, the automation software. And then we started to look at, well, why does that happen? And then we looked at the engineer's sequence of operation. We looked at the automation code written by the control contractor. We looked at the ASHRAE standards. And we also discovered that the fundamental contractual terms between the owner and the architect and the engineer and the control contractor sort of left a gap between different silos. And that's where the problem starts. So the first thing that we do when we evaluate a building is we look at the ASHRAE standards, and then we look at the sequences as written by the engineer. And also we have to understand the intent of the engineer. In general, we don't find that many design problems with the buildings. Generally, the engineers can follow ASHRAE standards. It's with the writing and the communication of the sequences that are key. And then, of course, we look at what did the control contractor actually deliver. So if the engineer writes something that's vague, he can't program it correctly.
So let's pause it there. So, Robert, you're a practicing engineer still, unlike myself, I don't know what I'm doing at the moment. But
well, and just to clarify on that, Adam, you probably didn't get the memo, but as of this year, I've actually retired my engineering business. But carry on.
Oh, well. Okay, then in that case, you are free to tell the truth. I shall assume you are liberated.
I am liberated. Set me free.
Free to tell the truth. So as a nearly ex-practicing engineer, how in-depth did you go with sequences of operations?
Well, and that was a big part of our contract, right? And, Bill, your comments are bang on. And the control side of it is incredibly important. It is a piece of the puzzle though, right? It has to fit with all the other pieces of the puzzle, the building, the architecture, right, the interior design, the mechanical systems. The control part of it, though, sits on top of all of that and has to manage it in order to, be congruent with the design intent. And for our practice, because our practice, was based on learning lots of things in the past that were difficult, and of course we incorporate them into our new systems and design procedures. We spent a lot of time on developing sequence of operation. That was a big part of and that was one of the more challenging tasks. And Bill, you make a statement in one of your presentations And people need to understand this, that when you buy, and this is your quote, when you buy automation software, you don't buy it from the manufacturer, you buy it from the local technician. I don't know how important that, that is, people need to understand that, because we've done projects, all over North America. And one of our key messages to our clients is that you design your control system as much around a standardized package as you can, and you count on local support. That is your number one decision you make, is who are the local folks? Because ultimately, when that control system gets commissioned, if it's not singing and dancing the way it's supposed to dance, it's going to be the local guy, not the manufacturer, that's going to come to your rescue. So, Adam, I don't know if that answers your question, but yeah, we spent a lot of time on it.
Yeah, I think there's a gap between some engineers in Canada, for example, who I used to work with closely, used to not want to write the sequence of operation. They thought that was a control guy's job. So they would effectively outsource that and just stamp it. Now, that's Canada. Now, Bill, you're in the States. How is that there? Who tends to take responsibility for this aspect? Do the designers do it, or do they try and slop it off onto controls engineers?
Nobody takes responsibility.
Yeah.
So I want to go back to Robert's comment about the local technician.
Yeah.
So one of the weaknesses in the building delivery, automation delivery process is the control technician. What's happened is the software is written by the local tech. The local tech is not supervised and really doesn't follow standard software practices. So in today's society, when you build software, you have to, you have certain ways you write software. You comment on software and you structure software. That's not the case of what the control companies have done with their automation technicians or software technicians. Each one operates on their own. There's no one who oversees their delivery. So I pointed out, we kind of discussed earlier, there's different silos. The engineer does this, and they do the best they can with the sequences, but they never really get much feedback on sequences, so they don't really know how good their sequences are. The control guy job is to get the contract done and say, hey, I met spec, I'm out of here. Then you add in the control companies as a business is really a hardware business. They're not a software business. So they don't take the discipline of writing software and maintaining software the same as, like software companies do today. So that's another weakness in the delivery process. I just wanted to touch on Robert's comment on that, because that's another critical piece of why you get inefficient automation.
That's an interesting point. I like that point. People should sort of take a pause and underline that. So controls firms, we're talking about the big boys, Siemens, Johnson's, all these guys. They're in the hardware biz, not the software biz. And this is where I think part of the problem lies. There's an expectation, I think, of controls software to be like Windows. You open a box, it sets itself up, and off I go, right? And it's not like that. Really, controls software is a bit like a row of crooked teeth. Everyone's in business for themselves, right? And no one's really straight. Yeah. Would that be fair?
Yes. So the control companies have a business model. The other thing we want to not forget is that while control software runs, all the buildings, as the building becomes more sophisticated, as the mechanical design evolves, then you're back to writing really custom software for that particular building. Even though it can be componentized, it's still unique for that building. So just like the mechanical design is. So that is, another contributor to why you get inefficient automation. And that's what runs the building.
So Robert, to your perspective as a design engineer, if this console sequence keeps bouncing backwards and forwards to you, that's basically a loss of time and money for you, right?
It is. And going back to the complexity of designing, constructing, and commissioning buildings, the more silos in the whole process, the more complicated it gets. With integrated systems, of course, a lot of those are solved. But I want to come back to Bill's statement, in terms of customized software and customized control solutions, that has always been, the bane of our existence. We've been up the high-tech ladder doing customized stuff. And these days, as we winding down our business, our past projects have been focusing on standardized stuff. So in other words, we'll go to the manufacturer's catalog, look at their standard product offering, and design our control systems around that rather than dealing with the customized stuff. Because, again, what Bill made a statement there, that the local guy, there's some good guys out there and there's some and not so good guys. I'm going to say guys. We're referring to both guys and girls because we've had both, both genders on that are in the control business. But the customized stuff is just, it's like kryptonite. I don't know how else to put it, And the problem is that when you look at the silo-based design, construct, commission systems, you're working from the outside in. You have some client and architect has this perception of what the building ought to look like, and then everything is designed from the outside in. Nobody looks at how the thing's supposed to work, 24/7, 365, like the guts of the building, right? And that comes after the fact. But in fact, if you reverse that process, you'll find that you can use the control automation, the control software, and that can lead you to actually designing better buildings. I want to throw a comment out at Bill here, which is to get your opinion on this, because last year we had Zoltan Nagy on. Zoltan is a professor out of the University of Texas. He and his colleagues, and this might blow you away, they did a literature review of over 5,500 papers. The DNA of that research project was to look at the terminology that's used in papers related to buildings. And what they found was shocking. In over 5,500 papers, there was no connection between the word thermal comfort and the building automation system. In other words, when you looked at all of the terminology used in the papers, when a paper was written about building automation system, it never, or if it did, very small print, referred to thermal comfort. Or if you read a paper about thermal comfort, it very rarely referenced the building automation system. Such a huge disconnect, Bill. 5,500 papers and the two subject matters don't come together. Is that your experience?
Well, I think it is. I mean, when you look at the specs, the engineering specs, they do say thermal temperature comfort or thermal comfort. But when it's outside of that, no. I think it's surprising there's that many papers. But yeah. The purpose of the control system is to deliver comfort in every space and health and safety in every space, which means ventilation or the right amount of fresh air at the lowest energy cost.
Yeah.
So that's another connection that isn't very strong. And there's also, I think someone else mentioned on one of your podcasts, there's a big focus on energy savings. And there's not a focus on operating consistent with the ASHRAE standards, which will give you thermal comfort, meet the health and safety requirements at the lowest cost. So one of the things that I think is doing the industry a disservice is such a strong focus on energy savings. Not that you don't want it, and you do want to operate at the lowest amount of energy, but the disconnect from good operations is not helpful.
I agree. I mean, the issue I think is you're after energy savings, but you're also after sort of indoor air quality to deliver ventilation rates, and you're also after persistence of performance, right?
Right.
Some systems are all over the place with persistence of performance. Now, a lot of that is down to system selection. Like a VAV system is all over the place. I could give you a whole 2 hours where you should never put one of them things in. But, the control system's trying to do three things, I think. Persistence of performance, so be consistent, deliver indoor air quality and thermal comfort, right? And on top of that, we want to manage energy consumption. That's a lot to ask for something that you're trying to take off the shelf and not modify or develop like specific code for specific projects, right? It's a lot to want and not pay for, really.
Yeah. I agree with that. The not paying for it part. There's, when I think about like design and engineering buildings is actually a pretty straightforward process. And that I mean, as a longtime member of ASHRAE 55, which is the thermal environmental conditions for human occupancy, we know the combination of architecture, building sciences, interior design, and mechanical systems. What is the Rubik's Cube, if you will, that's required to create comfortable spaces. But when it comes to controlling those spaces and controlling the devices that contribute to controlling those spaces, people underestimate the value of the building management system and the software that goes into it. And that undervalue makes it very difficult in a competitive marketplace to actually do what is probably necessary. Bill, you have any comment on that?
Yes. And one of the things we've done to address that is what is the real cost of inefficient automation software over the life of the building? And so there are 4 ongoing costs that are affected by automation quality, efficient versus inefficient automation. And that is energy, maintenance labor, equipment life, and frequency of recommissioning projects or engineering projects to make the building run better. So, we created a financial model to show how those 4 costs run out for 20 years. And if you have inefficient automation, those costs, all 4 of them, will be higher over the life of the building, which we said 20 years for the control system. And what we can show is that if you get it right early on, let's say by the end of the warranty period, then the net present value or the net present avoided cost is very significant. And that's the one thing when we start introducing that to the owners, they start realizing this because they've only been dealing with energy cost. They haven't been looking at all of the things that affects. And when you start to put automation in the context of affecting 4 different unique cost centers over the life of the building, then they start realizing, well, maybe we need to understand how to get this right in the first place.
Yeah, that sort of leads itself, I think if you take that logic to a conclusion, that lends itself to a subscription model of support for firms like yourself, right? For firms that have that combination of controls expertise, systems engineering expertise, and coding expertise, right? Would you? That sounds like good business to be in to me.
Right. So there's a part of the business that says you have to help the engineer improve the sequences of operations so you can hold the control contractor accountable when they go ahead and implement their job.
Yeah.
And then, of course, you have to know what data has to be collected in order to monitor the building so it is operating consistent with design intent. And then you have to be able to evaluate that on a regular basis once the building is running. And that's the monitoring-based commissioning. But a lot of what we see is that if you don't get it right in the first year, boy, it's really expensive to get it right later on.
Right. Absolutely. Bill, we had Bjarne Olsen on, who was the ASHRAE president of last year. And of course, he's one of the professors at the Danish Technical University. Now, I've heard him talk many, many times, and he makes reference to this ratio, 110 to 100. $1 representing over the life of the building would represent the utility cost. $10 would be the rent cost, and $100 would be the cost per person in the building. So 1 to 10 to 100, and the message there is that the true cost in any building is the people cost. Now, people, if they're not happy with the space, are going to start to mess around with the control systems in an attempt to get back into this comfortable state. So your analysis here, talking about after 20 years, the cost of a bad system, you start to understand just how complicated and how difficult and how miserable the results of a bad control system can be, because at $100 cost to 10 to 1, anytime you can get a 5% increase in productivity due to a good environment, that just makes everything else in the chain look like belly button lint. Like utilities become non-consequential, right? But if the control system is really bad, then all of a sudden, you're fighting to try to get the building under control. Never mind increased productivity, just to get the building under control.
Right.
So these numbers, become significant. Instead of 100, maybe that number's way bigger than 100. You know what I mean?
Right. Sure.
Yeah.
We've also noticed that it seems to take about 3 years, 2 to 3 years of tinkering with the building before they get into a stable condition. Now, that may not be efficient, but stable. So as the buildings get more sophisticated, then what we can see is that the amount of effort that goes on in the first several years to try to get the building operating, reasonably well, which means mostly comfort, that's very high and it's very expensive. And my financial models didn't model that in. But for owners, that is a huge distraction of maintenance resources. When you think about it, it's a new building, should run well. And yet, their resources go. They take their maintenance resources, they throw them at the new buildings, and they can't work on some of the older buildings.
Yeah.
So,
God, you've hit the mother load of problems there, because what you're talking about is, let's say I'm a owner, I take over a new building and the controls are still not set up properly. Then my FM guys start fiddling with set points because they're not sure. They get a call, they change a set point, get a call. So that's a whole negative feedback loop, right?
Yeah.
To use an incorrect controls terminology. But the other thing is this, that thing you said there, about 3 years to get the building control system operated properly. I agree with that 100%. The problem is the way buildings are procured. So everyone before substantial completion is only concerned with first cost and getting the hell out of Dodge, right? Then you hand that over. That's when the problems really start. So it's fundamentally a problem of how we procure and hand over buildings, I think, is one of the big issues. That's really a cultural phenomenon, I guess, or a contractual phenomenon. I don't know what the answer is to that. Have you seen any solutions for that?
Well, that's one of the things we communicate to the owners, is that their own process for the acquisition of buildings helps contribute to this particular problem.
Yeah,
and
agreed.
And there is a reality that the engineers are there to get a certain job done and get out of Dodge. And same thing with the control. So all of the construction process is geared about getting the building up and running, and that's very critical. You have to do that. And then there's a panic to get people into the building, and then of course everyone starts leaving. So it's important to let owners know that their own purchasing process does contribute to this, and therefore they need to think about certain ways to evolve their purchasing process, or more importantly, their warranty process. And what we recommend is in the design phase, you build certain things into the design phase, or better, that's why you have to build in better sequences into the design phase, so you can hold the control contractor accountable during the warranty period. And again, it's the specificity and accuracy of the sequences of operation that are critical to help the control contractor understand how it's supposed to be programmed. Because if they're handed something that's vague, what do? They're stuck. So they got to find some way to get the job done and leave.
Yeah, they copy and paste the last job they did. That's what they do.
There's a really important message in here for our audience, and that is that, and this goes back to some of the communication principles, Adam, that you and I have talked about in the past, and that is, in the absence of information, people will make up their own crap.
Yes.
Right? Because they don't have any other choice. So the more vague the specifications are, you're basically just inviting all of the headaches to come into the building, permeate the structure, and it will last for years to try to get it resolved. Having said that, I want to go back. I want to talk about, what happens over the life of a building. So the building starts out as a brand new building, brand new control systems. It takes 3 years to get it up and running. Finally tuned it all up. And then what happens is that the client, puts the purchasing department in charge of services and, materials. And one thing that I think, Adam, you and I have both agreed on is that there's two things that you never allow a purchasing manager to buy. You never let a purchasing manager buy the building, and you never let them buy toilet paper.
That's so true.
Right? Because they don't know. And so what ends up happening, and I've seen this happen over and over and over again, that a building gets designed, built, commissioned. 3 years later, you hand it over, and the thing's working fine. And then the year after, the fourth year, right, they have an issue, because they always will have an issue. So the purchasing manager ignores the original team and says, well, we can get a cheaper service. And so they hire somebody else. So now you got a new guy on the team, right? And he comes in and he basically says, well, the original team did this wrong, they did this wrong, this is wrong, blah, blah, blah. And so now they start to modify the system. All right, so that's year 4, but that happens in year 5, 6, 7, ... to the end year. And by the time that building is 40, 50 years old, it has had so many therapists, aka control contractors, that the building is a mess. It's everybody that's gone in there has had their finger in it, and now it's a complete mess. And when what should have happened is on year 4 is that the purchasing guy should have gone back to the original team and said, here's what's going on. But they don't do that, right?
Yeah, there's another piece that we see is that the engineering firms, the sequences of operations are very hard to decipher for anybody. And one of the things, so you can think of someone 3 years down the line, okay, they're going to try to read it and interpret it. So the engineers, I think, also need to deliver more clarity, not only in the way the narrative sequences are written, but we're recommending operating state diagrams. So that will show basically the basic performance of the building or the basic theme of how that building should run, because very few operators are actually introduced to the basic way the building is supposed to run.
Yep.
So that doesn't help either. And Robert, you were touching on a little bit about persistence. So sometimes what we see happen, once you set up the software, if you don't touch it, it's always going to run that way. So if the building's always going to be inefficient, it's going to continue to run that way. Sure as shooting, because it's software, it just runs.
Right.
But what sometimes happens is certain weather, patterns change quickly, and all of it, that's when people start tinkering with it. Now, I think people start tinkering with it because they're so used to tinkering with it because it doesn't come out right in the first place. So the persistence, if the software is right and you don't touch it other than, certain minor changes, which you can do, then it continues to run efficiently. And I think a lot of people, if something isn't right, then they'll start tinkering, which actually makes it worse.
Yep.
So, people really want to have persistent. When they call persistent, I think they don't realize it wasn't set up to be persistent.
Yeah, I agree with that.
And so that's another thing about, efficient automation or software that does exactly what the design intent has to be, 24 by 365. Mm-hmm. So that's another piece of the puzzle. But again, it goes back to you got to get the software right. And that means the technician who writes it has to be good. That means the sequences have to be good. That means you have to communicate to the people who are operating building what the design intent is. So there's a bunch of pieces that aren't quite connected. And those pieces are the ones that affect the way the initial delivery of the automation, and then how people tinker with it later on.
The Edifice Complex will continue in just a moment. If you're enjoying this podcast, we need your help. We're not asking for money, just a minute of your time. Our goal is to make the Edifice Complex podcast as relevant, educational, and useful as possible. By having good ratings, we can reach the widest audience. Therefore, our request is 2 small things. If you haven't already, leave us a review and rating on iTunes. And subscribe to the Edifice Complex on YouTube, even if you normally only listen to the audio version. These 2 things will help us immensely. Also, if you would like Robert or Adam to speak, teach, or consult on your project or business, please email admin@edificecomplexpodcast.com. Thanks for your time, and now back to the show.
One of the things sort of coming out to me here, one of the key things that's missing, or one of the key things that's vital when you're running a building, is having the skills and the competence in-house to deal with this, right? Because you need the skills and competence to recognize what's going on from a systems engineering point of view.
Correct.
And then the skills and competence to do something with a BMS other than fiddle with the set points, right?
Right.
And that's the missing piece, because most FM contracts are bid on 0.5%, 1% profit margins. You're not getting that competence in that profit margin, right?
Right.
So, it comes down to how mission critical your building is. If you're running a biohazard lab or a data center that's got 99.999% uptime, then this matters, right? I guess if you're running a hotel, not so much. But I have seen the solutions. I do have a solution for this problem and seen it work. But Bill, in your sort of mind, if I could wave a magic wand and say, right, Bill, you can do what you want, what would you do to make the control system work as effectively as possible from the get-go and then on into the future persistently?
Well, that's where we go back to a better sequence of operation, a sequence of operation that is guided by operating modes. So in other words, or operating states, as ASHRAE calls it. So they've got some diagrams that define how the building's supposed to run across the different weather patterns. So when you're in heating mode, when you're in economizer mode, when you're in free cooling mode, when you're in mechanical cooling mode, those are all known states. And I think what should accompany the narrative sequence of operation are these types of diagrams, which lots of people can understand. That's one piece of it. Two is the owners have to have better guarantees in their contracts. And then the control companies need to improve the quality of their programmers or the standards by which they have software delivered. What do you call 100,000 buildings, control systems out in the field? I call that a software business. Right?
Yeah.
Yes.
And it can be a standard way that, yes, you have technicians locally install it, but there's an engineering manager who makes it consistent across the different ways. And we see, not only you've heard of point names being named differently, but the code is written differently, and there's no consistent way maybe the comments are written in that. And then what will happen is the automation will be verified to be in conformance with the operating states during the warranty period. That's the key. That's the part of the process that is very weak right now. And that would be where I would say the owners will get the greatest benefit. And I think the engineers benefit because they find out better how their designs work.
You're assuming they want to know.
Well, they may. Yes, I do. Well, you asked me.
Sorry, Robert.
It's so true.
All right. So I was at a conference this last weekend, and I heard there was a presentation by an application engineer at Belimo talking about their latest whiz-bang stuff. And there was something in there that was said that really interested me. He said, valves in the future will be data acquisition devices. Now, that piqued my interest because one of my bête noirs is IoT. I believe in it, but the application of it might be not as straightforward as people think. But let's just think of a hydronic system, so a massive chill water system, and there are data acquisition devices on every terminal. So that means the BMS or the BAS, if you're in North America, can collect real-time data on flow and energy output for every coil. At that point, you don't need tab, and you have real-time. If you've got the right algorithms in there, you have real-time, instantaneous, optimal operation of every system, right?
Yep.
So how far off do you think that utopian is?
Well, I think from the manufacturers, I think that's not far off.
Right.
I think that's possible, and I'm happy to hear that. The trick is that you're getting more and more devices connected into the controls. So the light, a lot of times we don't find the lighting control system integrated well with the BAS system. So, you can control the shades, you can harvesting of daylight. There's a lot of different components that can go into operating the building and, the security system. Well, all of those are great things, but it's going to boil down to how do you write the software that actually deals with all that data?
So there's an integration issue to be solved, really.
Correct. Yeah. One of the things we're a big proponent of, and the other co-founder is going to be speaking at ASHRAE this in Kansas City. He's going to be conducting a debate, and the debate is about component-based or subsystem-based controls, where you have a main control manufacturer and you have someone like for fan wall systems or chiller plants. Those are engineered systems. And that the debate is going to be: do you have engineered systems where you connect to effectively a subsystem, or do you have the control system actually try to control that too? And we say no. Go ahead and you buy the fan wall system for the fan wall manufacturer and the chiller plant system, because those are hard systems to know how to optimize, but they have to have a good interface between between themselves, and the control manufacturer has to be able to understand how to program or how to properly interface with that particular system. So I think it's great that the valve manufacturer is thinking in terms of, hey, my job is to output data. That's correct. But it'll boil down to how well can you write the software that's going to take advantage of all these different systems.
Yeah, I mean, current state of play on a job I was on recently was there was a great chiller and it had this bespoke internal software running it, and all the BMS or BAS could do was send a run and enable signal to it. Otherwise, there was no data acquisition that the BMS could do. So you had this quite intelligent chiller, a reasonably intelligent BAS system, and they weren't really talking well to each other other than please turn on, please turn off, which sort of defeated the object in a way, I thought.
Right, but there should have been more data that had been transferred between the two.
Yeah,
even
absolutely.
the chiller's running on it. It's one thing that the chiller or the chiller plant can run on their own, and they know what to do, and they have their own controls to do that. But the other part of it is, what data did they transfer back to the control system for it, so at least you can monitor it?
There's some monitoring data. When I challenged the chiller engineer, he said, we really don't want anyone accessing our data. So all they send back is basic run, enable, and trouble signals and alarm signals. But he says, we don't want anyone interfering with it. It's an intelligent piece of equipment. You let it do what it does and, go away. So, he was adamant that was how it should be. But, I don't think the future would embrace that very well.
It will not. You're going to have to deliver. I mean, there's a lot of important parameters of how the chiller runs. He can send that information back without losing control.
True. Yeah. Again, then it becomes proprietary information. And are you willing to give it up, I guess, as a manufacturer?
But, look at it, if you take a practical example, and of course the Danes are very good at this, right, where all of their heating and cooling plants, the efficiency of those plants is monitored as a function of return temperature, right? So if you got 1,000 buildings on a system and they're sending water back in the heating mode at too high of a temperature, then you destroy the efficiency of the boiler. And likewise on the chiller plant, right? Yeah. So the modern control systems are monitoring the return temperatures, they're monitoring obviously back at the main plant, but it's really important that they monitor the return temperatures coming out of each of the buildings, because collectively on a weighted average, that return temperature is going to drive the efficiency of the plant. So you can't disconnect the buildings from the systems. And, and to hear a chiller manufacturer say that, you don't mess with our equipment, it's a standalone device. Yeah, I would have an issue with that on a job site.
I had a very big issue with that, but I just didn't get anywhere because they were bigger than me.
Yeah.
Well, it's interesting why he would say that, because that's not working to his business advantage. I want them to define how it runs, and I want them to take care of its optimization. Right. But some of the chillers can turn down, and that's great. And you want to take advantage. The valve guy was telling you exactly what I think is the right thing for the industry, which is to make the data available. Now, they'll control it themselves and they'll know how it'll perform. Perfect. So you want to have, in the future, you want to have more and more of these subsystems, each one knowing how to operate itself and optimize itself, but it shouldn't be controlled by a central control. It should send back, it should interface, the interface is obviously critical, but it should send back the pertinent information.
What was interesting when he came out with that, I guess, buzzword sentence, valve as a data acquisition device, the thing that occurred to me is if there was sufficient of these devices in the future, it brings a lot of accountability to the design and construction team, right? Because you're seeing real performance in real time. Yep. You could trend log that, you can set alarms, going in and out of tolerance, but at some point it's going to show how good or bad these buildings are designed, and that will be another whole can of whoop-ass that gets opened, I guess. But I personally look forward to that future, because real-time feedback on how things are working is the only way to control it. This is why energy models suck mostly, right? Because they're based on assumptions on blue sky thinking. Totally.
I'm with you on that one, Adam. I mean, you ask any energy modeler, most of them have no practical building experience to begin with. A lot of them are just computer jockeys. And I apologize to those that actually have some skills in the building side of it, right? But nobody, for example, will take a look at how does imbalances in a building affect their energy models, right? And going back to the guys in Belimo as a data acquisition tool, I mean, with a delta T and a flow, you got BTUs, right? So if you've got BTUs on a particular air handling unit and you've got weather data, well, then you should be able to compare those two and say, okay, well, the building was designed this way. We selected the air handler this way. This is the load at this weather conditions. Is there congruency? If there is, and there is, and everything's running, then you've commissioned that particular part of the system. If there's no congruency, then you have a problem, right?
Yeah. And what that will lead to is the elimination of oversizing, probably, right?
Bingo. That was my next statement. That's one of the things that it does, is it eliminates the oversizing because it holds people accountable.
Yep.
Right?
Yeah. We just solved a massive problem there. Maybe. In theory.
I think that's a very important point, is that, every other industry is using data more pervasively. And you get better because you have that data coming back to you. Mm-hmm. So that's where the industry has to go to, provide the right comfort, the right health and safety requirements, and at the lowest energy cost.
Yeah.
Yeah. It's funny, Bill, and Adam, we talked about this, is that when you look at the majority of buildings in the continent of North America are under 20,000 square feet. Many of those buildings do not involve the professional engineer or, control technician. A lot of them are just wholesaler driven, contractor driven, right?
Yep.
And, I don't know how many, this is my 40th year in the business. That's why I'm shutting down my engineer. I'm done. But, we would go to job sites on a peer review, for example, and, we'd walk into mechanical rooms and we would see these walls of pumps, 20, 30 pumps. And we would ask the contractor, well, who engineered the system? Well, we did. Well, did you do a wire-to-water efficiency analysis? How many BTUs per kilowatt of power are you moving, right? And nobody does it, and I'm looking at it. And, of course, for those that are listening to the podcast here, on a good day, on a really, really good day, a wet rotor circulator might be hitting 17, 18% efficiency, right? Yep. So you go into a mechanical room and you start counting pumps, 20, 30 pumps, right? And you start to think to yourself, well, 18% efficiency, the rest of this is just heat and noise and vibration. And you're asking yourself, no automation system is going to correct that mistake.
Correct.
Right?
Yep.
And so that, again, goes back to the disconnect that occurs in industry, the silos, not holding people accountable for the energy use and the efficiency of the systems in the building itself. And that's an epic problem everywhere.
So, Bill, in your business, you're presumably working with a lot of end users, correct?
Yes.
How are they? I mean, you're working with them, so I guess they're buying what you're selling. But are they starting to understand how this works? Do you think you've got them for the long term?
Yes.
Good.
Oh, yeah. After the thing that's critical to get them to understand how important the automation is, first we usually run into analyzing existing buildings. And then they start to realize, when they see a review of the sequences, when they see a review of the automation code, when they see the data, and you start putting all those pieces together, then they go, so that's really the thing, because no one's ever put those pieces together in a concise way so you connect the dots for them. They've suspected it for a long time, but they never could get a clear answer on it. Yeah. So what we see is that for owners, that's getting them to see why the building is running the way it is, be it the sequence issues or the automation issues or the way it was programmed. That's critical. What we're starting to find in the construction industry, the construction side of this, which could be owners, a lot of owners have their own construction side of the business. They're very familiar with why does it take so long with so much effort to get the control system running right. So once and that is a good introduction to, here's the inherent nature of the problem, and this is what you do to fix it or to minimize it. So I think there are actually a lot of people that are familiar that relate to that catch line. Why does it take so long with so much effort? So I think we've made a lot of progress in the last year or so, year and a half, with that statement, and then being able to explain it to people. And once they see it once or twice, then they're kind of on board with it.
So we're coming up on the hour, but I just want to tell you about a story of a job I did. It was a long while ago. I can't say what it was because we had to sign an NDA, but it was a massive data center. And it was it was a construction project, right? And it'd be handed over, and none of us were going to be involved post occupancy. But the control system was so vital to keeping the uptime thing going that the way we did it was during design phase and early construction, we did really detailed sequences of operations with network diagrams attached, which then went backwards and forwards 2 or 3 times between the contractor and the engineer. Then the engineer finally signed them off. Then they went to some bench testing, and then they did a really intense commissioning and functional performance testing process. And that is one of the very few jobs I've handed over where I could put my hand on my heart and say everything actually worked. But the effort that involved was just phenomenal, So on a AAA data center or AAA office or a biohazard lab, totally justified. But that, if you put a gun to my head and said, what's the solution? That's it.
Right. And that's where having the data getting collected early on in the design, and where you get, when you're inherently better at writing sequences, where you would make that a more scalable issue, because you went through a process that can be, the labor time for it was very high, but it can be reduced, if you're practiced at that kind of focus.
Yes.
And you have the data tools and the expertise on the control and the programming side to solve that problem. And you can do it in much less time and effort, because you're right. It was a mission critical data center. It had to be up all the time. It had to have the right environmental conditions. And what you went through was a process that gets you what you need. It's a very expensive process. And so that process has to be reduced in cost a lot. And some of the tools that are now, becoming available allow you to do that.
Yeah, it's always a money thing, right? Ultimately, find the right people with the right skills and throw money at them is how you solve this problem. The question is scale, right? And automation, ultimately. Right. But I think you're in a very good business there, Bill, because one of the sessions I attended on the conference was from an engineer from the city of New York, where they have mandatory retro commissioning going on to try and reduce the energy consumption in the existing building stock. And it was really interesting hearing the problems he was coming up against, which is basically having people with the expertise and skills to do it. And the control systems is the perennial problem. Yep. And, I think any business that is focused towards retro commissioning and sort of taking on old building stock and making that work better is going to be in a good spot for the next 10 years, in my opinion. How about you, Robert? What do you think about that?
Yeah, I agree.
The skill set is a big deficiency in the industry today.
Yeah.
And therefore, you need to bring the data back to the people with the high-level skills.
Yeah.
And you can have just you can have very few people with the high-level skills. And if the data comes back and the analytic tools allow them to evaluate the situation in a short period of time, then a few experts can actually process a lot of buildings, many, many more than are processed today.
Yeah, I think that the people that are going to hit gold are the people that can reliably automate these situations or make them a lot faster as a process-driven thing.
Yeah, right.
I mean, if you've got the operating conditions of the building, at the various weather points, that's your check ultimately, isn't it, on the mechanical systems? Again, going back to return temperatures, right? Well, if the people in the building don't have the skill level to understand the importance of that, or they don't have the data, then what do they have to compare it to? How do they know that the system's working as intended?
There are people that are good at looking at the information with all of the skill sets that can consume the information. And then you have to have people out in the building to actually fix things.
Yep.
And there's actually, I think, a decent skill set to fix things. It's the interpretation of the data, which is where the skill sets are lower and I think inadequate. And it's also time consuming. The other thing is, if you want to get good at evaluating a building using data, you can get really good at it, but it takes work. You have to have practice at it, like anything else. But now, so you make your analytic tools reduce the labor time for the analyst. And you're still going to need an analyst. You can't take the analyst out of the picture, particularly as the buildings get more sophisticated.
That's my advice to any young graduating engineer right now today is do courses and develop expertise in data analysis. and statistical analysis, because that is going to be a key skill in the future for your job.
Yep.
Yeah.
So, Bill, we're coming up on the hour. Sorry, Robert, did you have one more question?
No, well, other than just to comment that there's one thing to analyze the data and then adjust the building parameters or do whatever is necessary, but ultimately, you've got standards like ASHRAE 62.1, 62.2, 55, all of these standards, and the people that are responsible for managing the data, acquiring it, and then what do you do with it, also have to have the ability to say, well, how does this information relate to the standards that the building were designed to?
Yeah.
Right. You analyze the building, you evaluate a building based upon how it's performing against the standards.
Yeah.
Right.
Yeah.
62.1 spells out very clearly how much air you have to have how much fresh air you have to have in every space. It may not get programmed that way, but those are things. ASHRAE has figured out a lot of the work. So when you analyze, you should be not what your opinion is. What does ASHRAE say?
Yeah. Imagine the future, right? When air measuring devices are data collecting devices and they're accurate. So you can measure accurately hydronic flow and airflow. Then you get real performance information.
Right.
Yeah.
So at the end of every podcast, Bill, we always ask our guests some quick fire questions. So there's no prizes, but we do record who does what, right? So here we go. No pressure. First question is, what advice would you give for women in technology and engineering, graduating or who are thinking of going into engineering?
Let me think. If that's what you like to do, then you should do it. And you should recognize that there are new disciplines being added to your engineering field. And that will be around data, but you're still going to have to know the fundamental physics and disciplines that exist in today's world. And you're going to be adding new disciplines to the future world.
That's a very good point, the new disciplines thing. People should take that on board because, I think in the next 10 to 20 years, our business will evolve very differently to what it is now, right? Due to technology impact.
Right. And I think that's, everyone, men and women. So everybody, that's where, at least in the industry we're talking about, there's a new discipline being added to that, and mechanical engineers are going to have to know data better.
Yep.
Yeah, totally. So I want to follow up with Adam's question, and again, this is for the architects in the world. Bill, because you've been involved in many, many buildings, and of course, all buildings do not perform the same, and some are, ugly ducklings and jackasses. Others are thoroughbreds and run really well. If you had any words of advice to young architectural grads, what would that be?
What we've seen in the young architects is that they actually have more, they seem to have a lot of interest on how well their baby performs. And I think now, what they can bring to the architectural world is the ability to actually make sure that the way the building is architected actually operates that way. Whereas in the past, that hasn't really been possible. So the young architects of today, there's a new opportunity for them is what their fathers couldn't do was actually make sure the building operates the way you want it to. You've architected. The architects put a lot of time and effort into thinking through a lot of details in the building. And what's happened in the past is they're very disconnected on whether or not it performed consistent with their intent. Mm-hmm. The new architects and the new engineers can actually do this because of the world of data and real-time analytics and all the sensors that are going in. So that's going to be what they can bring, is the next generation can bring something that the past generation couldn't bring because it was impossible to do it.
Yeah.
Yeah, that's a very good point, actually. And graduates now are so much more technology aware and technology enabled, if you like, for want of a better word. I think that's a good confluence of influence, because what you're bringing with an architect is the art and the technology, right, together in a building, which is very important.
And I think a lot of them, care, but there's so much effort to find out if it really worked that way. It's like, I'm on to the next job.
Yeah, there's no doubt about it. Some architects are glory boys, right? And they just want to move on to the next drawing. But some of them really are technology geeks. It's quite interesting actually seeing those two sort of roads in architecture develop. Okay, well, I think we're coming to the end now, Bill. So I just want to thank you very much for coming on, and thank you for being an advocate for this subject. This is a subject dear to my heart as a commissioned engineer, and I think it's a very poorly understood problem, right? And it's a problem that's solvable, right? It just needs the right mindset and thinking in the early stages of a project, in my opinion.
It's absolutely solvable.
Adam, another great guest. Somebody we sort of haven't touched that topic before.
Yeah.
So kudos for getting them on, because it's a big part of our world, right?
Yeah, I am convinced data acquisition and analysis and using data as a control tool for building systems is a lot closer than people think, possibly 5 years away, maybe 10. And I think it will fundamentally change the way building performance is seen and managed. I really do.
Yeah. Yeah. And real-time data tells a lot, doesn't it? I mean, we talked about, I don't remember who was on it. Maybe it was Ed Aarons that was on, and I suggested that there's no reason why post-occupancy evaluations the data from post-occupancy evaluations can't be piped into the training facilities at the universities that are teaching architects how to design buildings. So if post-occupancy evaluations are coming in at 20% when they should be 80%, that's a 60% failure, and students ought to see that.
Actually, yeah, open sourcing that data for educational purposes would be awesome. What a research tool.
Oh, yeah. Because it would point out, like, okay, so why do we have such epic failures in buildings? And there should be a great big screen in every architectural class showing the current state of satisfaction in buildings. Data, from building management systems there's no reason why post-occupancy evaluations can't be integrated into a building automation system.
No, not at all. I'll tell you, man, we are entering a brave new world at the moment. And it was really eye-opening, the conference I went to the other day where, this is a valve manufacturer. When he came on, I thought, oh, God, I nearly fell asleep, But he was awesome. And he spoke about valves in a way that was really game-changing. He was projecting the future that they've already invested in and are manufacturing for. This wasn't an idea. This is something that's rolling off the production line right now, right?
Yeah.
So if you think this isn't going to impact you, if you're an engineering man, think again. This is coming down the road.
Yeah. I always love it when sales guys use the word, the concept here is, there's no concept. No. This is a product in production. The concept was already considered decades ago.
Yes.
Somebody had a vision that data acquisition using a valve is going to be the way of the future. We're past the concept stage. Now we're implementing.
This is a strange thing in our business, like old Scotty on Star Trek. Yeah, can he change the laws of physics, Captain? Right? The fundamentals of our business have not changed ever. Right?
Yeah, exactly.
Somehow the application of those fundamentals just gets mullered.
Yeah.
But data will show, to use the Warren Buffett example, who's swimming naked when the tide goes out, right? You're really going to find out who's winging it, who's miming to the song. You're going to find this out real soon.
Yeah, totally. He made a good comment. I mean, all of our guests have such great wisdom, but one of the ones he said, and I thought was one of the pivotal statements in the interview, was the new disciplines that will come out in the future. We're starting to see it now. We're going to see more of it evolve as buildings evolve and as these new technologies come into their own right. And I think this huge, and you said this many, many times, that the opportunities for the new engineers coming out is huge. Just make sure you pick the ones that give you the opportunities.
Yeah, that's what Steve Burrows said. What the best time ever to be an engineer, and he's at the end of his career like me, and you, I guess now you've retired. Yeah. And he can just see how good it's going to be. When you're in school and you're like buried in assignments, it's hard to put your head up and see this, right? Yeah. But you think about it, 25 years ago, there was no job called web designer, right?
No.
Or social media analyst. These jobs have just erupted in the last 5 or 10 years. That phenomenon will happen in our business. I am convinced of it. There will be job titles in our business 10 years from now that don't exist today.
Totally, I agree with that.
And I will feel inadequate looking at it, probably. And that's a good thing, right? Because my time's come and gone, and it's someone else's time. That's awesome.
Yeah. Well, there's a great, and again, this will show my net savvy, social network savvy. Is it a meme or a mem? M-E-M-E.
Oh, my wife and I have this debate. I say it's a meme.
There's a meme, and forgive me if I'm pronouncing that wrong. There's a meme on Facebook that showed, I think it was the top 20 corporations in the world going back 25 years. And it's an animation showing how the companies have changed. So at one point it was Coca-Cola, right? And how Amazon came up through, and you can see Amazon coming up through the ranks year after year, and then voila, they displaced the top leader, right? And we're going to see that happen in all kinds of industries, and we'd be naive to think that it's not going to happen in the building industry. That's just stupidity. What we know today as leadership in architectural and engineering is going to get displaced. There will be something come up, and it'll say this is a new way of doing it. And anybody that's in the old way of doing it, you're going to be moving down the ladder, and everybody else is going to be moving up. Data is going to be one of those things.
Yeah, I agree. I mean, when I first started, one of my early mentors who was a great engineer said, Adam, this CAD thing's never going to catch on. Don't worry about it. Now,
that's hilarious.
He's an awesome engineer, but his time came and went, right?
Yeah, sure.
I think if you're a practicing engineer today, if you were to say you're between 30 or upwards, you're faced with a pretty binary choice. Either embrace this change or just get pushed out the way by it. Because if you do not embrace this change and get to understand the data issues and the technology issues around these systems, you're going to get crushed, in my opinion.
Yeah.
And, that's an opportunity for people. I guess there's a Darwinism to that, right? The good people change and evolve, and the dinosaurs are dinosaurs, right? And you wind up checking their bones 2,000 years later.
Yeah. I think one of the things that I just came to my mind that we have to be really aware of, and that is change for the sake of change is not right. You know what I mean?
Yeah, it's got to be a benefit.
Yeah, and I think for the practitioners that we ought to be uber critical of manufacturers that use technology as a means of supporting future revenues. In other words, you know what? Industry may not need this, but our company needs the revenues.
Yeah, well...
And so we're going to do a hell of a marketing public relations program, to make this thing happen. Come hell or high water, you have to adopt.
Yeah. So what most manufacturers are like, contractors are like the scorpion and the frog, right? They always the frog's carrying them across the water, and the scorpion always kills the frog. So most manufacturers, they're really trying to get proprietary systems and information out there that they can control and only they can license. But I think this integration, this need for convergence and integration is just going to overwhelm that business model, because one of them will break ranks, and then it will start.
Yeah,
that's my view. But the problem with contractors and manufacturers and controls hardware people, man, they are scorpions, and they're forever killing that frog that's taking them across the road. Always.
Yeah, totally. Yeah. Awesome.
Anyway, mate, so that was a good episode. I'm looking forward to getting that out there and getting some feedback on that. But, controls, it's not voodoo, guys. It's just there, right? It's basic engineering. It's the application. That's where the superstars are found.
Yeah. This goes back, probably my last comment on this particular interview is that, but you and I, again, have talked about it because we've talked about so many good things, is that when you hire an engineering grad, let's take an example, 2 engineering grads. One of the grads worked his way through university, 3-4 years of doing the academics, but also getting his hands dirty, getting onto job sites, working with the equipment, understanding the if-then statements, because that's what we're talking about is if-then statements, right? That's a totally different grad student than the student who didn't get his hands dirty during those 4 years. The girl that has worked with the mechanics and the electronics and the software and the building management systems over their summer holidays, my gosh, they're going to be leaps and bounds ahead of anybody else. So my advice, we didn't talk about it, but for those that are coming out of school or going into school, the parents that are listening, get your kids or get your, the students, get out onto the job sites and learn about the mechanics, because you can become a software junkie or jockey, a data jockey. But unless you understand the if-then that happens every time an air handler is called to fire up, the boiler, chiller, pump, any control point, thousands of control points in a building, all of them have an if-then statement associated with it. Learn that stuff.
Yep. Big salaries are at the convergence of applications, engineering, knowledge, and data management and controls management, right? You got to have all that, or you're just a nobody. Or an also-ran.
Yeah, put that in the show notes. That was a good piece of information you just said.
Okay, then, man. I'll see you on the next one. That was awesome.
All right, Adam.
Take care,
man.
Cheers.
Right,
bye.
You've been listening to the Edifice Complex podcast with Adam Muggleton and Robert Bean. To access show notes for this episode, visit edificecomplexpodcast.com. Also, if you would like Robert or Adam to speak, teach, or consult on your project or business, please email admin@edificecomplexpodcast.com. See you next time.
Adam, it's time to thank some people who are on our side because we're on their side. You found a new tool, software, Blue Rhythm commissioning software.
Robert, I sure have. I think Blue Rhythm is what I've been looking for all these years. Building commissioning can be chaos at the best of times. Most projects I consult on really suffer from poor information management. You know, it's 2019, yet the property and construction industry seems to be firmly stuck in the 20th century paperwork world. I think people mistake emails and PDFs and Microsoft files on their servers and all the different PCs as a digital solution. In reality, it's just unorganized chaos. Do you want to streamline your commissioning process and save time and money? Do you want to go paperless and increase efficiency? Blue Rhythm is a cloud-based software solution built specifically for building commissioning professionals. Blue Rhythm digitizes your custom forms and checklists, allows collaboration across project teams, and automates reporting, leaving you to focus on what matters. Their team help you onboard the test sheets you've developed over the years. You can even send it to them in paper, and they will digitize that and put it in the Blue Rhythm system for you. In my opinion, Blue Rhythm pays for itself in time saved on paperwork on a single project. For a demo or to start a free trial, go to bluerhythm.com. That's where rhythm is spelled RITHM like algorithm. Bluerhythm.com. Tell them the Edifice Complex sent you there.